So we got a spring. We got a spring attached to the bottom of this beaker, and then this piece of wood gets attached to the spring. And what does the wood want to do? Float. It's going to pull the spring up. Okay, so the piece of wood, because there's a buoyant force on it, the piece of wood gets pulled up by the buoyant force, and it's simultaneously being pulled down by two things. So the start of this problem is doing a free body diagram for this piece of wood. So if we look at the piece of wood, sitting there, so here's the piece of wood. What are the forces on this piece of wood? It starts with the free body diagram. Well, what's pulling the wood up? The buoyant force. We have a buoyant force up, and then we have two forces down. What are the two down forces? Well, one is going to be mg for the wood, but look at let's not say wood. We got part of fluids is keeping track of your symbols. I'm going to call this mass of block, B for block. So this B up here is buoyant. That's buoyant. This B down here stands for block. Okay, what's the other force on the block? The spring is pulling the block down. You guys see that here? The spring is holding the block down. And what's the equation for force of spring? Force of spring is Kx, but actually in this problem they're calling it delta L. Okay? So let's just change this delta L to x. What's the elongation, the stretch of the spring? Okay. So now what we do is we sum, well actually before we go any further, what is buoyant force always equal to? This buoyant force up here is always equal to what? The weight of the displaced fluid, which is going to be mg for the fluid. And what's the fluid in this problem? Water. So see right there? That's why so W here is water. That's why I said B down here, because if we would have said mass of wood, then we'd have two W's going on. You know what I'm saying? So W is water for this problem, and then B is block. All right, so let's sum our forces. Here, I'm going to get rid of this. I need room. We'll get rid of that. Okay, so summing the forces, we have mass of water times gravity, that's the buoyant force, that's this guy, minus the force of the spring, which is Kx, minus the weight of the block. Okay, that's the sum of the forces. Sum of the forces always equals ma, okay, where this would be mass of block. But what's the acceleration? 0, because the block's just sitting there, right? It's just sitting there attached to the spring. All right, so now what are we trying to solve for? X. We're trying to find out how far the spring got stretched. Okay, so X, when you do the algebra, is going to be equal to mass of water times gravity minus mass of the block times gravity divided by the spring constant. Okay, there's only one more thing to find. And if you haven't heard this yet, fluids are tedious, guys. Have you noticed that? A lot of like solve for this, solve for that, solve for this, solve for that. Okay, what's the missing thing now? We know what gravity is. We know gravity. We know the spring constant. The spring constant's given. We got the spring constant. We have the mass of the block. The mass of the block is 5. What do we got to find? The mass of the water. Okay, so how are we going to find the mass of the water? Let's do that up here. So finding the mass of the water displaced by the block. So how do we do this? Well, what do we know? The block is fully submerged, right? So what's going to be true for the block? So you've got this beaker of water here, right? The block is fully submerged. So the volume of the block is going to equal what? the volume of the water. If an object is fully submerged, the volume of the object equals the volume of the fluid. That's the easier situation. So we first got to find the volume of the block. What's the volume of the block? Okay, how do we find volume of the block? Well, density equals mass over volume. So what's volume going to equal? Mass over density. So the mass of the block is 5 kilograms. The density of the block is 650. That's a given. So the volume of the block turns out to be it's 7.6923 times 10 to the negative third cubic meters. That's the volume of the block. So what's the volume of the water? How much water gets displaced? The same exact thing, because it's fully submerged. Okay? So now that we have the volume of the water, we can find the volume, the mass of the water. Now that we have volume of water, so density equals mass over volume. So what's mass going to equal? Density times volume. So what's the density of water? 1,000. The volume of the water displaced is the same as the volume of the block. Fluids are tedious. Okay, so we find out that the mass of the water, this ends up being 7.6923. 7.6923 kilograms. Gravity is 9.8. Let's make some room here. So 9.8. Mass of the block is 5 kilograms. And then the spring constant is 160. So I guess the hard part here is finding the mass of the water. I mean, if you understand this, what we did up here, this is like, that's the physics. That's like, summing forces. But then once you have that done, you just got to do algebra and figure out the mass of the water. So this all works out to be 0.165 meters. That's the answer, or 16.5 centimeters.